Hi, welcome to Algebra 2 Common Core. Today in lesson number 2, we're going to work on reflecting functions over different axes. So let's take a look at exercise number 1. We're given the parabola f of x with the equation x squared minus 6x plus 5. We want to consider the new function g of x, which is the negation of f of x, minus f of x. Determine a formula for g of x and graph it. So let's start first of all by looking at the table of values for g of x. So I want to create a table showing the points that we have graphed here. Let's take a few minutes to write down a table of values for the ordered pairs on the graph given to us. So I've created my table right above the graph. Now what we'd like to do is first of all consider what happens when we are negating each f of x value. That just really means we're going to negate the y values. So let's make a new table of values with each of the y values negated. So this is going to be my new table for g of x. Notice that the x values stay exactly the same, but the y values get negated. So 0, negative 5, 1, 0. 0, of course, when I negate it, is still 0. When I negate negative 3, it's going to give me a positive 3. 3 will be matched with 4. 4 will be matched with 3. 5 will still be matched with 0. And 6 is going to be matched with negative 5. So I've negated all of the y values. I'm going to go ahead and graph that, but then I'm going to come back and make the formula for g of x. So pause the video, take a few minutes to plot these points, and graph negative f of x. So I have graphed all the points for the blue function representing g of x. Let's go ahead and find the formula for g of x. We know that g of x is just equal to the negation of f of x. So g of x is going to be the result of taking negative 1 and multiplying by my function x squared minus 6x plus 5. So to get this new equation for g of x, we're going to say negative x squared plus 6x minus 5. You could also check this on your graphing calculator. If you enter that new function into your y1, you should see the graph that we've just created in blue. Now clearly what we have done for the graph of g of x is do a reflection over the x-axis. The manipulation that we did, we negated the y values. Now let's look at part C. Consider the function h of x, which is equal to f of negative x. We want to determine a formula for h of x and graph it on the grid above as well. So let's do the formula first of all. So if we want h of x, that's equal to f of negative x. So this time we are just going to replace every x in our equation of f of x with the negation of x. So our h of x equation is going to be negative x, that will be squared, minus 6 times negative x plus 5. So the equation for h of x is going to be equal to x squared plus 6x plus 5. Now take a minute and let's make a new table of values for our h of x function. This time, instead of negating the y's, we're going to go back to our original table of values and we're going to negate each of the x values. So take a few minutes and do that, pause the video, and come back when you've completed your table. Here's the table of values that I produced in red that's the result of negating each of the x values. Now I'd like you to pause the video, plot these points, and connect them to get our new graph of h of x. Come back and check your work with mine. I've graphed the new graph of h of x in red, and as you can see in part D, what we have done is taken our original graph that's in black, the function value f of x, and we've reflected it over the y-axis this time. So this is just a reflection over the y-axis. The manipulation that we did, we negated each of the x coordinates. Let's summarize this information in the box in your notes. When we're reflecting functions in the x and the y axes, the first kind that we did, negative f of x, reflected the function across the x-axis. Remember, all we did was negate the y values. When we made the function f of negative x, that reflected the function across the y-axis. And that was the result of negating the x values. Now in exercise number 2, let's take a look at a different parent function. I've got the function f of x is equal to the square root of x. We want to start by graphing the square root of x. Now if you don't remember what this looks like, enter it into your graphing calculator. But you should recognize that f of x equals the square root of x is going to be the upper half of our sideways parabola opening up to the right, so it looks like this. Now for part B, we want to graph negative f of x. So remembering what we wrote above, negative f of x should just be a reflection over the x-axis. So we're going to take that parent function, and when we reflect it over the x-axis, it should look something like this. For part C, f of negative x should be a reflection over the y-axis. So again, I'm going to go back to my original function that we drew in part A, and when I reflect it over the y-axis, it should look like this. So I can see both kinds of transformations. One, the reflection over the x-axis, the other, reflection over the y-axis. And I should be very familiar with these two kinds of reflections. Looking at exercise number 3, it says if a parabola has the equation f of x equals 2x squared minus 3x plus 8, which of the following represents its equation after a reflection in the x-axis? So if we are reflecting in the x-axis, that means that we want to negate the function value. So we want to take negative f of x. So this is just going to be the negation of 2x squared minus 3x plus 8. If I calculate that, I should be getting that my new function is negative 2x squared plus 3x minus 8. So looking for that function, I see that is choice number 2. And again, I could graph the original one on my graphing calculator, graph my choice on the graphing calculator, and see if it looks like a reflection over the x-axis. In exercise number 4, we are told that we want to do a reflection in the y-axis. So we're starting with the quadratic function g of x is equal to 4x squared minus 7x plus 2. So if I'm doing a reflection in the y-axis, that means that I want to find g of negative x. So let's replace each x in my function with a negative x. So I want 4 times negative x squared minus 7 times negative x plus 2. So the function that I'm looking for would be 4x squared plus 7x plus 2. And of course, this is choice number 3. In exercise number 5, we want to consider the function g of x equals negative x squared plus 4. There are 2 transformations that have occurred to our parent function y equals x squared in order to produce the new graph of g. Now, we can actually look at this in 2 different ways, so I'm going to set this up as 2 different columns. In the first case, I can say, let's start with our x squared. If I've negated the x squared, that means that the first transformation that I have done is a reflection over the x-axis. But then after we reflected over the x-axis, the second transformation that has happened is I have taken my graph and I have vertically shifted it up 4 units. Alternatively, we could take our function g of x and we could write it in a different way. We could say that g of x is the negation of the function x squared minus 4. So in this case, we want to pay attention to what is inside the parentheses first. So our first transformation in this case would be a vertical shift of the parent function x squared down 4 units. But then once I vertically shift the parabola down 4 units, the negative in front of the parentheses would be a reflection over the x-axis. So I actually have 2 different ways of getting this new function g of x equals negative x squared plus 4. If you plotted both of these transformations on a piece of graph paper, you'd notice that you would get an upside down parabola that's been shifted up 4 units. In exercise number 6, we are told that the point negative 1, 4 lies on the graph of the function f of x. So the question is, what is also on the graph of f of negative x? Well, f of negative x is, of course, our reflection over the y-axis. So we are going to negate the x-coordinate, or the x value. So if I negate the x value, that tells me that my function negative 1, 4, or I'm sorry, my point negative 1, 4, which lies on the function f of x, would get transformed by the transformation f of negative x into the point 1, 4. So this is a way of showing it as a mapping. So I'm going to choose option number 4. For exercise number 7, I've recorded the ordered pairs that are graphed for the function f of x. What I'd like you to do is take a few minutes and do each transformation, part A and part B, creating a new table of values and then plotting those points. Come back when you have both part A and part B completed and check your work with mine. Welcome back. Let's look at part A first of all. You'll notice that the blue graph is the reflection of the original graph over the x-axis. We created the new table of values by negating each of the y values. Looking at part B, the red graph is a reflection over the y-axis. We negated the x values to create our new table of values. So in class, you're going to need to be very familiar with both kinds of reflections. Make sure you understand which of them represents negative f of x and which represents f of negative x. Thanks for working on reflections today. Have a great day, and we'll see you in class.